Hello everyone, welcome back to Bimbel Bilcen. In this video, we are going to learn about quadratic equations, simultaneous equations related to quadratics, and also quadratic inequalities. So let's jump into the video. So in this video, we are going to start with the review. We know that we have three methods to solve quadratic equation. So we have factorization, we have quadratic formula, and in the previous video, we have learned about how to do complete in a square. So we are going to apply these three methods to solve some kind of equations. Yeah, so let's look at the first type of equation, which is simultaneous equation. So you already learned about simultaneous equation. If you have two equations, or maybe a function, if we talk about functions, and we want to find the intersection points, what we can do is we can equate the equations. So if you look at the first function here, we have y equals to x squared minus 4, and the second one is 2x minus 1. And if you want to find the intersection point, if you look at the intersection point, they share the same value of x and the same value of y. So we can plug in the value of y, can equate them, becomes x squared minus 4 equals to 2x minus 1. Now from here, we can just solve the quadratic. So x squared minus 2x minus 3 equals to 0. From here, you can do factorization because it can be factorized easily. Here we have x, and then we have 3 and 1. And then to get minus 2, we need minus 3 here and plus 1 here. So we will get x equals to 3 or x equals to negative 1. So this is how we find the intersection point. And let's take a look at a harder example here. From past paper, summer, paper 1-3, 2017, question 3. So the question here, we have find the coordinates of the points of the intersection of the curve y equals to 2 over 2x exponent 2 over 3 minus 1 with the curve y equals to x exponent 1 over 3 plus 1. The keyword here is point of intersection. That means we can equate the curve. So here we have x exponent 2 over 3 minus 1 equals to x exponent 1 over 3 plus 1. From here, we can simplify first the equation. We can collect all of the term to the left side, becomes x2 over 3 minus x1 over 3 minus 2 equals to 0. Now, if you look at this equation, it doesn't look like it is quadratic equation, but if you pay attention to the power here, we have to the power of 2 over 3 and the power of 1 over 3, we can rewrite the equation as x exponent 1 over 3 square minus x exponent 1 over 3 minus 2 equals to 0. Now it looks like a quadratic equation. We can change it into quadratic equation. So we can change the x 1 over 3 becomes another variable. Let's say it's u. So let u equals to x exponent 1 over 3. Yeah. So if we do that, we get u squared minus u minus 2 equals to 0. Now we have quadratic equation. We can solve it. So we have u and u over here, and we have 2 and 1, and we have minus 2 and plus 1. So we have u equals to 2 or u equals to minus 1. So now we can plug it back because we want to find the coordinates, which is x and y. So we plug it back the u. So it becomes x exponent 1 over 3 equals to 2 and x exponent 1 over 3 equals to minus 1. So here we can have x exponent 1 over 3 equals to 2 and x 1 over 3 equals to minus 1. So here we have cube root of x equals to 2 and cube root of x equals to minus 1. Keep in mind that cube root can gives you negative number. Yeah. So the second equation is valid because cube root can gives you negative output. So from here, what we can do, we can cube root both sides. So we get x equals to 8 or x equals to minus 1. Now, we have the value of x because you want to find the coordinates, we need to find the y as well. So we can plug in x equals to 8 to one of the curve. Let's plug it to this one. So y equals to, wait, I think it's easier if we plug into this 1 over 3 only. So y equals to 8, 1 over 3 plus 1. So it gives you cube root of 8 plus 1, which is equals to 2, plus 1 equals to 3. Now, the second one, we have x equals to minus 1. So we plug into the second equation, becomes minus 1 to the power of 1 over 3, or we can just rewrite it as cube root of minus 1 plus 1, which is equals to minus 1 plus 1, which is equals to 0. So now we have the coordinates. The first one is 8, 3, and the second one is minus 1, 0, guys. So that's how we solve the simultaneous equation to find the point of intersection. Now, we also have some similar equation. Let's look at some more complex problem. It doesn't look like it is quadratic, but we can change it into quadratic, guys. So the first one, solve the equation 8x exponent 6 plus 215 x exponent 3 minus 27 equals to 0. Now from here, we can just look at the equation here. Look at the smallest power, which is x3. Yeah, so we can change this into 8 x3 squared. It becomes 8 exponent 6 plus 215 x cubed minus 27 equals to 0. And once again, we change the smallest power that we have into another variable, let's say u. So let u equals to x cubed. So we have 8u squared plus 215u minus 27 equals to 0. Now from here, just factorize. Here we have 8u squared and 27. So we have 8u, and this is to get 215, so that should be 27. And this is u. This is 8u. And then we have, this is minus 1. This is plus 27. So if you multiply 8 with 27, you get 216, and then minus 1 become 215. Now, so from here, we can have the first one is u equals to 1 over 8 or u equals to minus 27. And what is u once again? U is x cubed. So plug it back. X cubed equals to 1 over 8. From here, we get x equals to cube root of 1 over 8, which is 1 over 2. And the second one is minus 27. So x equals to cube root of minus 27. And that gives you minus 3. Now, we also have another type of question like this with different power like this for x minus 11x half plus 6. And we can change it into 4x half squared. So you have to look at the pattern here. Usually we look at the smallest power, which is half, and look at this one. Oh, that is x half at being squared. So we can rewrite like that. Minus half, so 11x half plus 6 equals to 0. Use the same method. So we use substitution. U equals to x half. So we get 4u squared minus 11 u plus 6 equals to 0. Now, from here we can just factorize. So we can have, this is for u, this is u, and then we have 2 and 3 over here. So minus and minus. So we have u equals to 3 over 4 or u equals to 2. And we have u is x half, which is square root of x. So square root of x equals to 3 over 4 or square root of x equals to 2. And to get x, you just need to square both sides, become 9 over 16 or x equals to 4. Another kind of question, we have this kind of problem. 3 times 9x minus 28 times 3x plus 9 equals to 0. The same method here. If you look at this, yeah, 9x is basically 3 squared. So 3 squared x minus 28 3x plus 9 equals to 0. Now we can rewrite this. 3 to x becomes 3x squared using the indices rule like this. So same thing. So we have substitution for 3x, and you can convert that into x quadratic equation like this. Yeah. So the goal to solve this equation is to try to find a way to convert it into quadratic and you solve it. Now this one, pretty simple. You can factorize it easily. We have 3u and u, and this is 9 and this is 1, minus minus. So you have minus 27 minus 1, you get minus 28. So we have the first one is u equals to 1 over 3 or u equals to 9. And we have u is 3x minus x. So we have 3x equals to 1 over 3 or 3x equals to 9. So from here, we can change the base so they have same base. So 1 over 3 become 3x minus 1 and 9 is 3 squared. So from here, we get x equals to minus 1 or x equals to 2. Pretty simple. Yeah. The goal is to convert the quadratic equation so that the equation that you have to become quadratic equation. Now, we also have quadratic inequalities. Instead of having equal sign, we can also have inequality. You already learned about inequality. So let's apply it to quadratic inequality. Guys, let's move on to the next question about quadratic inequalities. So we have a curve has equation y equals to 2x squared minus 6x plus 5. The question is find a set of value of x for which y greater than 13. So here we have inequality. The approach a little bit different. So we plug in the y first, becomes 2x squared minus 6x plus 5 greater than 13. From here, we can simplify, becomes minus 8 greater than 0. And then we can divide both sides by 2 to simplify. Now, here we have the quadratic inequality. What we can do first is we can factorize. Yeah. So here we have x squared, x, and we have minus 4 can gives you minus 4 and plus 1 over here. So from here, we have 2x-intercept. Now, for solving quadratic inequality, we can sketch the graph after finding the x-intercept. If we look at this quadratic factorized form, we have two x-intercept. Yeah, the first one is x equals to 4 and x equals to -1. Now, we can sketch the graph first. Yeah, we can sketch the graph. We have two intercept, which is -1 and 4. Yeah, and then we can sketch the graph for the quadratic equation before we factorize, which is x squared minus 3x minus 4. Because the coefficient of x squared is positive, we can draw the parabola facing up. Yeah. Now, this quadratic has to be bigger than 0. So we take the graph, part of the graph that is above 0. This is the 0, right? This is where the y equals to 0, which is x-axis. So we take the part of a graph that is above x-axis or y equals 0, which is this one. Now, we look at the value of x for this part. Yeah. So this one, the value of x is from -1 less than that because going left. So we can write x less than -1. Or we take this graph, which is to the right of 4, or x more than 4. So this is how we solve quadratic inequalities. Now, we also have harder question. Yeah, this is taken from past paper. Let's look at the question. The function f is defined for x element real by fx equals to x squared minus 6x plus c, where c is a constant. It is given that fx greater than 2. Find the set possible values of c. Okay, now we can plug in the fx first. So we have x squared minus 6x plus c greater than 2. Now, this question a little bit different from the previous one because now we have plus c. That means we don't know the value of c, so we cannot factorize it because in order for it to factorize, you need to know the value of c. So what we can do, we have to do a different approach. One of the approach is using discriminant, but we will learn that later in the video. I'm going to do the second one, which is what if we do completing a square? And why do we do completing a square? You'll see why later. So here, we do completing a square. So we have x minus 3 squared minus 9 plus c greater than 2. Because you want to find the c, so we isolate the c. So we have c greater than 11 minus x minus 3 squared. Now, so the value of c always be bigger than 11 minus x minus 3 squared for any value of x. But we know that this expression, x minus 3 squared, the value always positive. So x minus 3 squared always greater than 0. So if we take the minimum value, which is x minus 3 squared greater or equals to 0. So the minimum value is 0. So we will have c greater than 11. And if we take a value more than 0, let's say it's 1, so you will get c more than 10, which is still more than 11. So we take the general solution, which is c greater than 11. So that's the answer. Thank you for watching this video. I hope you like this video. Don't forget to hit the subscribe button and keep watching the next video so you understand how to do quadratic problem in Cambridge. Thank you.